Okay, so now we're on question number 6. And on question number 6, they're asking us, what is the surface area of the image shown below? Now, I know this is not a special right triangle question or a Pythagorean theorem question. It's not even a trig question. But it's a good question to keep us on our toes and remind us how to find the surface area of polyhedrons. So if I look here, the first thing I should ask myself is, well, how many surfaces does this shape have? Well, it has one triangle here, one there, that's 2, a rectangle in the back, that's 3, a rectangle on the floor, that's 4, and this rectangle right here kind of that you're looking through, which is 5. Okay, so let's say I want to find the area of this triangle here, right? Well, it's a right triangle, I see that. They tell me that this is 4 and this is 5, and if I remember correctly, the area of a triangle is half the base times the height. Well, they gave me the base, they gave me the hypotenuse, but I don't have the height. So how do I find the height? Well, one, you could use the Pythagorean theorem to find this missing side here, or you can remember the magic numbers that we discussed in class about the Pythagorean theorem. Like, for example, if this is 5 and this is 4, you should know automatically that this number here is going to be what? 3, because 3 is one of the set of magic numbers that we discussed, 3, 4, and 5. Well, now that I have the height of this triangle, well, now I can find the area of it. The area of a triangle is half the base times the height. So it's going to be half of the base of 4 times the height of 3. Well, 4 times 3 is 12, and half of 12 is 6, which means that the area of this triangle right here is going to be 6 centimeters squared. Well, I have the exact same triangle over here. This is 4, this is obviously going to be 3 as well, and this is also going to be 5. So this triangle here is also going to have an area of 6 centimeters squared. So this part is 6 and this part is 6. So 6 times 2 is 12 centimeters squared. So I'm done with the triangles. Well, now let me look at this little quadrilateral down here, right? This is a quadrilateral. It's like a rectangle. It's the base, right? Well, this side here is 4 and this is 12. So the area of this quadrilateral is the base times the height, or the length times its width, which is going to be 4 times 12. So 4 times 12 is 48. So the area of this down here is going to be 48 centimeters squared. So I've taken care of the two triangles, and I've taken care of the base of the rectangle here. Well, now let's take a look at this rectangle in the back that's standing up here, right? Well, I know that it's 3 centimeters high, but the question is, how long is it, right? How long is it from here to here? Well, remember that this line is 12, right? So this line here is also going to be what? 12. These are parallel sides. So it's 3 by 12. So 3 times 12 is going to give me 36 centimeters. So the area of this rectangle back here is going to be 36 centimeters squared. And now all I have left to do is to find the area of this rectangle right here, the one that I'm kind of looking through, right? Well, I know that it's 12 centimeters long, and I know that this hypotenuse here, it's also its width, it's 5 centimeters. So it's going to be 5 centimeters by 12 centimeters. And 5 times 12 is going to give me 60 centimeters squared. So when I add up all of these surfaces, 6 plus 48 plus 36 plus 60, I add all those together and I get my answer, which is going to be 156 centimeters squared, which is choice C. Okay, so just a little refresher there on surface areas. We did kind of use the Pythagorean theorem here to find the height, and then we went into our formulas. Let's move on to question number 7. Okay, question number 7 here. Okay, question number 7. They show me a ladder. They show me a wall. Again, what's the first thing that I did? They show me an angle. So the first thing I did was I labeled my triangle, right? Well, if this is my 90 degrees, this is my hypotenuse, this is the opposite side, and this down here is going to be my adjacent side. Now the question, you have to make sure you read it very carefully. It says that a 20-foot ladder is leaning against a building and makes an angle of 60 degrees with the ground. So obviously we can see here's the ladder, it's leaning against the building, and there it's 60 degrees with the ground, right? Well, the question is asking us, how far from the base of the building is the foot of the ladder? Well, here's my ladder, and I guess this would be the base. Here's the foot of the ladder, right? They're asking me, how far from the base of the building, or here's my building, how far is it from here to here? Right? That's what they're asking me. They're not asking me how high this wall is. They're asking me how far is it from the base of the ladder to here. So think about that for a second. What are they asking me to find? They're asking me to find the adjacent side. So let's take a look here. They're asking me to find the adjacent, and they gave me the hypotenuse. So right there, I have the letters A and H. A and H. I'm looking for the adjacent, and they gave me the hypotenuse. So out of my three trig functions, so, ka, toa, which ones have the letters A and which ones have the letter H? Well, it's going to be the ka, right? The CAH. And we know that ka stands for the cosine. And the cosine tells me that it is the adjacent over the hypotenuse. Well, what's my adjacent? X. There it is, X. And what's my hypotenuse? 20. So it's going to be X over 20. So what I'm going to do here is I'm going to take the cosine of the angle. The cosine of 60 degrees is equal to the adjacent X over 20. And that's how I'm going to set it up. Now, the cosine of 60 degrees, when I type it into my calculator, is 0.5. And that's equal to X over 20. I want to get rid of the denominator. That's the first step I want to do. I always want to get rid of the denominator. How do I get rid of that denominator? I multiply across the equal sign. So I'm going to multiply 20 times 0.5. So here I got 0.5 times 20, and that's going to be equal to X. Look at that. I got rid of the 20 in the denominator. That's why I did that. Well, now when I multiply these two together, it's going to be equal to X. 0.5 times 20 is 10. So I got 10, and that's going to be choice C. By the way, if you got choice D, that means that you solved for the height of this wall here. You probably did O over H, and you probably used the sine function, and when you were looking for, what you found was the height of the wall, which is not what they were asking you. They were asking you for the adjacent part down here. If you got 17.3, that's probably what you did. Let's move on to question number 8. Okay, so question number 8 is a chord question. It's a circle, a question. It's a chords in circle question. And of course, yes, it has nothing to do with SOHCAHTOA. It has nothing to do with special right triangles. It has nothing to do with the Pythagorean Theorem. And I know some of you probably lean that way because, you know, you're so into the mode of doing special triangles or triangles in general. But what this was, guys, just again, was just a little refresher question, a little question to remind you of what happens when you have chords inside circles. Well, first of all, let's see what they tell me here. They tell me that AOB is perpendicular to CD. Why did they tell me that? They told me that to see if you could remember the rule. What happens when I have a diameter and it's perpendicular right here, right? It's going to make 90 degrees. It's perpendicular with a chord. Well, what happens is that diameter bisects the chord. It's going to cut that chord into two congruent parts, and that's what's happening here. And that's important because that's going to help us solve the question later. So that's the first thing they told me. They told me, listen, this diameter is perpendicular to this chord so that you know that it bisects this chord. And by the way, if you're not really sure or you don't remember, you can go onto the YouTube page and the videos on chords is there, and you can review it anytime you want. So guys, make sure you go ahead and do that. Okay, next, they tell me that OA is 6. And by the way, OA is a radius, right? The distance from the center to the edge of the circumference, that's 6. Which means that this radius from O to B is also going to be what? Is also going to be 6. So I know that they tell me this is 6. Then they tell me that O to E is 2. Okay? And if O to E is 2, well, then I know that E to B is going to be what? It's going to be 4. Because if this radius is 6, then this radius is also 6. They told me that OE is 2, so that I would know that E to B is going to be 4. Okay? So far I filled in all the information. Now, what's the rule that pertains to chords inside of a circle? In case you forgot, what the rule says is this. The rule says that if I have two chords inside of a circle, their lengths may not be the same. For example, this is a diameter and this is a chord. Right? Obviously, a diameter is a special kind of chord, but if you look at this and you measured it with a ruler, they wouldn't be the same size. A chord AB and chord CD would not be the same. But the rule says that if the product, the rule says that the product of their parts will be the same. So here's the part where the chords intersect, right? So if I take AE and I multiply it times BE, whatever the product is of those two should be equal to the product of CE times ED. Again, Go back to the YouTube page, review this section. So let's take a look here. So here they tell me that this part, right? How long is this part here? It's 8. 6 plus 2 is 8. And this part here is 4. So 8 times 4 is 32. By the way, I wrote the rule here in algebraic form. AE times EB, their product is going to be equal to CE times ED. Okay? So this is 8 and this is 4. So 8 times 4 is 32. Well, then that means that when I multiply these two parts here, their product is also going to be what? Their product needs to also be 32. And they're going to be what? They're going to be congruent, the two parts, right? So now, when I look at my choices down here, I have all these choices to prove from. They ask me, well, you know, what is the length of CE, right? What is the length of CE? Well, CE could be 4 times the square root of 3. It could be 2 times the square root of 3, 8 times the square root of 2, or 4 times the square root of 2, right? But the thing is, whatever CE is, whatever CE is, well, ED is going to be the same, right? And when I multiply them together, they're going to be what? They have to equal to what? To 32. So what I did here was put whatever was here, I put it there next to it, and I multiplied them together because I'd be multiplying the two sides that are congruent. So 4 times 4 is 16. Square root of 3 times square root of 3 is square root of 9, which comes out to be 3. 16 times 3 is 48. That's not equal to 32, so that's not the length of that side. Letter B says that it's 2 times the square root of 3, right? So 2 times 2 is 4. Square root of 3 times square root of 3 is the square root of 9, which comes out to be 3. 4 times 3 is 12. Again, why am I multiplying it times itself? Well, because these two parts are congruent. That was important. That was the important part that they told us at the beginning. This diagonal bisects this chord, so these two segments right here are going to, these two parts of the chord are going to be congruent. So whatever I get here, I'd be multiplying it times itself there, and I'm trying to get it to equal to 32. Here, 8 times 8 is 64. I can stop right there. And the last choice, if you look here, 4 times 4 is 16.